There you go. So Houston Engineering, LiDAR 101. We're just going to talk about LiDAR in the civil survey industry that we use at Houston Engineering. The guy on the left is me. I'm Chad Qualley. I've been with Houston, going on 18 years now. I've been in LiDAR for 20 plus years, pretty much since the late 90s. So been in LiDAR a long time. Been a leader in survey technologies here for, probably the last 10 years. So a lot of technology is what I kind of live in.
My name's Erik Nelson. I'm the guy there in the middle. I'm a GIS analyst / senior technician here at Houston Engineering. I've been here 11 years. About as long as I've been here, I've been dealing with LiDAR, and that's kind of a continued thing for me at Houston.
Guy on the right there is Samuel. He's a new hire, Samuel Scarpel. Hasn't been here a year yet, but he's just taking all the information in from Erik and myself to become a leader. He actually has a computer engineering degree, so he's a computer programmer. So that's the team here at Houston on the LiDAR side. So HEI, you probably heard the name Skyscopes. We have a partnership with Skyscopes on data acquisition. So Skyscopes is by far the leader in LiDAR sensors, drones. They're just amazing at what they do with data acquisition in LiDAR. So we work really, really closely with those guys on a daily basis on acquisition. And there you can see on the right, Erik and myself staring at a screen looking ominous. So we are software specialists. We know what software it takes to get the LiDAR processed and maintain its ridiculous accuracies that it is capable of. And then we, more importantly, know how to get the software to be able to use the point cloud information, or we'll talk a lot about feature extraction. We're specialists in that. So this is a picture of Skyscope's, probably one of the latest, most high-end drones. The bigger thing that we want to show is that they're using top-of-the-line sensors. I mean, the sensor is the key to LiDAR. Sensor power, that is a Phoenix LiDAR Systems Ranger UAV that you're looking at there. Real high-end. When you say high-end, they're very expensive. But you have real high power. I mean, the big thing with these LiDAR systems is that to get the accuracies that we require as a survey company, they've got to be very powerful and high-end. So that drone is no slouch either. I mean, you can see it's taking, probably 16 to 20,000 milliamp battery, LiPo batteries on the top. Just that alone is a lot of weight. But that sensor weighs, I figure, about 20 pounds?
Yeah, that sensor weighs 20 pounds. So that drone itself is pushing the 55-pound limit on a Part 107.
Yep. So it's a pretty serious piece of equipment. All right, how does LiDAR benefit the project? That's why we're all here. That's why we want to, learn about LiDAR. So what we're talking about is how LiDAR is really kind of transitioning into topographic surveys. Us at Houston have taken it and just ran with it. So what we're doing is we're using LiDAR, whether it's used in a drone. Hey, that's kind of the buzzword right now, drone-based LiDAR. But LiDAR can be flown from a plane, from a helicopter, mobile. This is actually a point cloud, believe it or not, from South Dakota, down north of Rapid City. It's crazy. I mean, it looks like an image. I mean, it's really, really dense, and we will talk about densities in LiDAR, and densities are the key. Densities make feature extraction accurate. I mean, that's probably the biggest takeaway is when we have the density of this LiDAR, we can feature extract, making it usable, and we get to maintain the accuracies. Flexibility and time savings. So yeah, project-based LiDAR, benefits versus traditional surveys. So we're going to talk about all four of these things. Flexibility and time savings is probably the first slide that we'll go over. So there's a little GIF there showing a LiDAR sensor hanging above ground. Shooting lasers down to the ground. If we don't know what LiDAR is, lasers return off the ground. So the LiDAR systems that we send are sending, a powerful beam. It can hit and bounce off, probably anywhere from 1 to 7 things and then those returns will all come back to the sensor, and go from there. We're not going to get too into the weeds of how LiDAR works, but the big benefit is flexibility and time savings. Aerial-based LiDAR, huge areas we can catch and collect in a single day. We're collecting, hundreds of acres, in a single day easily now with a helicopter. The same sensor put on a helicopter, we're collecting huge areas in a single day. Requires much less time on site. I mean, a typical survey for, let's say, a 15-mile road corridor, it can take a long time. I mean, you're out there for multiple days, probably even weeks, to get all of the data needed, to be able to do a traditional design on the civil side. We're out there for, frankly, a few hours collecting data. It does eliminate scheduling hassles. I mean, aerial LiDARs, a little bit dependent on the weather. You're not going to go out there with a, $500,000 drone and sensor in rain. You're going to, go out there when it's a little bit nicer. Biggest thing is probably just getting the light to be right for collecting good pictures. And then we'll say surveying from an office chair after collection. That's the huge thing. You go out there, you scan it once with the LiDAR system. We survey it with feature extraction from a computer using software, and you can do that at any time after the collection's done. So say you do a 15-mile road project, and a year afterwards you want to do some analysis on something that LiDAR got, like, for example, the power lines and seeing the clearance of the power lines. Or say the road encompassed a bridge. You can do full clearances at every single location because we'll drive the mobile LiDAR under the bridge, and it's a full 360 scan, so it gets everything. So that's kind of the benefit of the flexibility side of LiDAR. Here we talk about quality and accuracy, and this is where I just cannot believe how far LiDAR has come in the last, probably 5 years. We're getting to the point now where the densities are just computer breaking. There's so much density. I mean, we're doing, like, for example, we did a bunch of North Dakota DOT projects, and we did one that was, I think, 14 miles for 11? 20 miles. And it was, the amount of data that we had, even after cleaning it up, was, in the billions of points. So billions of LiDAR points is a lot of data in size, okay? And don't get scared from that, because we're the people that have to deal with that size. We have the computer power to deal with that. The nice thing about it is we use feature extraction software to take that really huge dense point cloud and make it usable on the civil side. So we feature extract key points that a surveyor would be out there doing. Breaks, like centerline. Breaks at where the pavement falls off. We also do shoulder breaks. We also do ditch center lines, as long as we don't have water or really high vegetation. But we can do ditch breaks. We can actually do power poles really easily. We can do tree locations really easily. We can do fence lines really easily. We can do a lot of things from a computer desk using software and maintain all the accuracies. This isn't less accurate than going out there with a human being and shooting it, because of the point density that we have, and allowing the computer and the software to figure out where that location is and elevation is. So it's really amazing, the accuracy. I mean, when we do mobile-based LiDAR, we're actually having a problem checking the LiDAR and more showing the LiDAR's accuracy with traditional survey methods, because as you know, if you've used GPS has an inherent level of I don't want to say not accuracy, but we call it bounce. I mean, it has a little bit of bounce, so you can be a tenth plus or minus vertically at all times with GPS. Well, LiDAR is also shot with GPS, but it's shot using targeting, and it's shot above tree cover, meaning you won't have signals bouncing all over. So we're finding that the LiDAR is really, really accurate when you're driving it or flying it with a smooth sensor, like a helicopter or a drone. So we'll talk about that later in the projects and stuff. But yeah, most projects going forward are going to be a combination aerial and mobile LiDAR. Because the mobile LiDAR is just, it's impossible to beat the accuracy that we're getting out of it vertically. Cost, this always comes up. Cost has been an ever-changing thing. Sensors are expensive. The nice thing about us working with Skyscopes is that's where they live. They live in sensors. They live in having the latest, greatest sensors. So they deal with the cost. So what we get to do as a survey company is just give you the benefit of not having a lot of people on site and not having those people on site for a long period of time. Time costs money. So it's across the board probably around 50% less expensive than a traditional survey. And that's not just global. I mean, there's going to be a little bit more expensive ones for mobilization and a little bit less, you know, based on where it is. But we're seeing around that 40 to 50% cost savings. And again, that has to do with, you know, the team that we have at Houston being extremely, you know, proficient in software when they do that armchair survey when they're sitting at the office chair. So, but yeah, depending on project size, I mean, we're not going to get 50% cheaper when you're doing a quarter mile, obviously, because you have to mobilize and get some people out there. But you know, we've been doing a lot of those 10 to 20 mile LiDAR projects. We did 160 or 100 and plus mile power line surveys, and they're considerably less expensive when you get that big. Safety is a big thing. We're a survey company. Surveying on roads in particular is extremely dangerous. So we want to keep our guys off the roads. I mean, you can see that one picture there in the bottom. That's an actual point cloud again. Looks like a picture, but that's a dangerous place to survey. I mean, falling rocks possibly, but cars coming through there, being somewhere where you can't move out of the way, it's very dangerous. Flying a drone, shooting lasers, we're just seeing that it's just so much more safer to have just a small group of people out there doing that. So and that's why we've kind of seen that it's going to be a change, you know, in the industry to maintain that safety. And you can see there in the bullets, you know, we use trained pilots. These are full-blown pilots that work at Skyscopes. They're not just Part 107 pilots. I mean, they get to talk to other airplanes and do all kinds of, you know, things. And they fly helicopters. I mean, they do all kinds of stuff that is way above, you know, me and Erik are both Part 107. It's considerably above that. And LiDAR can be collected at night. I mean, I don't even think we've done one out of the.
I don't think we have. No.
We've done a lot of LiDAR projects, but we haven't done one at night. But we do have the ability to. We always do say, hey, if it's a busy area, so say, for example, like a busy urban area where a ton of people are parking there during the day, but at night it clears out, we can run a LiDAR scan through there, and it's going to have a lot less shadowing because of a lot less cars and stuff like that. So that can be done at night. The big thing that really makes the night stuff not happen is that the imagery has such a usable factor in the project, and we always want to have it. It helps a lot with feature extraction, but it also helps the designers do their design. Having a LiDAR and imagery at the same time is very important for that design. Cool little video. It's not the latest, greatest thing, but it's showing a drone flying. This shows, though, in the field, Skyscopes guys are seeing LiDAR hit the ground. So they know what they're getting. They know their widths that they're getting. They know their overlaps. So there's nothing missed. I mean, it's not like when I schedule or plan a project for those guys to go do, they're going to know that what they're getting, and they're going to get more than enough. So when it comes into the office, you know, typically the hardest thing is just say, hey, go from this mile to this mile and just, you know, make sure we get enough. So kind of an unnecessary video, but it looks cool.
This kind of transitions us into the project side of what we're going to go through in this presentation. This is actually a stretch of that North Dakota Highway 11 that Chad was talking about earlier. And it just goes to show you the density of the LiDAR itself. Through this 20 miles, I believe we had, I think it was close to 3.3 billion points to work on that. Like he said, you have to have a lot of horsepower and a lot of people working on it. We're able to just collect these massive amounts in, I think they did this in a day.
Yep. So yeah, I think if you hit next, it should.
Yep.
Yeah. So this is a good picture. I mean, you can see that's a linear road project. Okay. That is a down and back on either side, not above the road, but it's actually over kind of the ditch area, and that's just a down and a back, and that's the density that we're getting. So you can see we're getting possible drainage, you know, on the ditches just outside, and again, we can go wider, but I mean, this is just to show a typical linear road project using LiDAR. And, you know, the way that LiDAR works on these systems is that individually all those points are not really separate, but they're kind of each like a separate GPS shot, if you think of it. You know, so each of those is processed out to have its kind of inherent accuracies. It's not like, you know, older methods like photogrammetry that can have warpage, you know, where you start something and it kind of starts to build error onto itself. Here you can get individual point area, you know, inaccuracies, for example, like cattails or vegetation that you can't penetrate with light. Yes, I mean, LiDAR is not going to be accurate in that. You know, we determine those to be void areas. So void areas need traditional survey to go out there and shoot it. There always is going to be traditional survey. Don't get me wrong. I mean, we're a survey company. We want our surveyors out doing work. We just don't want them out here for a month doing 20 miles. We want them to go out here with a real specific scope of what they're doing. So they're shooting culvert inverts. They're shooting void areas. They're shooting areas of high vegetation. You know, they're frankly getting things that we know as LiDAR experts that are not going to be good enough for what we expect on the survey. And they go out there and they do additional survey, and then we actually can build that into our surface models and our feature extraction from what they're doing. So,
and going back to the surveying from the armchair, in this image here, you can see you have power lines, power poles, you can see fence lines, trees, you can see everything. You can go back to this over and over again and use this as long as it's relevant. And sure, if you do have a project going through there, you can collect before and after, and you have your before and after view of this particular area. So it's extremely usable in that sense.
and one little quick thing, you notice the power lines. I mean, going down and back, the density of these LiDAR systems hitting the power lines is crazy. We can pull all those power lines in seconds. It's pretty easy. So, all right, what's next? WABASHA County. These guys they're a county highway department down in southeastern Minnesota. They were one of the guys that just cold called me out of the blue and built a pretty good relationship with them. I've actually done, gosh, probably 9 projects, 9 project locations down there now. It's ridiculously not like Fargo. If you guys don't know, we're in flatlands of Fargo. This is very hilly terrain. I went down there and did a couple of the first surveys, and I mean, cell phones don't work. I mean, it's crazy. It's very hilly. And we kind of determined these things to be almost an unsurveyable thing. Not that you couldn't do it, but it's going to be a huge, huge pain because you're going from like these low areas in the Minnesota River and St. Croix, and you're going to these like higher areas, and you're traveling up, you know, hundreds of feet. Surveying is tough through there, and especially if you can't use GPS and it's shadowing off of hills and stuff, it gets to be a pain. We went through there with LiDAR. The GPS on the LiDAR is up above. It maintained its connection all the time. Sprayed, I think in this case, the sensor was spraying 700,000 points per second, and it just painted. This actually is showing bare earth, I believe. All those hills are covered in trees. I mean, this is very hilly, treed area, and they were super happy. We did feature extraction through it, and they did a road design that was going to take them a lot to do. So it's a real good showcase of what LiDAR can do to fix a problem.
Yep, and I can touch on some of the technical points on this. I did a lot of the feature extraction for these. With this collection, I believe our point density on these were like 60 points per foot. Not super great, seeing as this was kind of these were more or less our test projects in the beginning.
Very early. Yep.
And this is kind of showing what we extract from that point cloud. So going back and forth between those two, those are the same view. It really, it dumbs down the point cloud to a point where you have usable data in a CAD or a microstation environment.
And again, it doesn't, just because it's less dense doesn't mean it's less accurate. The accuracies and the vertical accuracies stay there. It just makes it a usable data set in a CAD environment.
So Highway 3 was actually our first North Dakota DOT project. I believe this was out by, what town was this? I don't even remember. It was between two towns.
Directly in the center of North Dakota.
It's directly in the center of North Dakota. So this was kind of our jumping off point with
Harvey, I think.
the DOT. Yeah, Harvey is correct. We learned a lot on this project. We spent probably a good month or more on getting the feature extraction down on this one. The shortfall of this project, I think what we figured out was what type of drone we used to collect. This was early on, and they were using a helicopter-based one-rotor drone, and we were getting some crab walk in there, and there was some deflection in there that kind of screwed up some of our accuracies. This one was a little bit better than the WABASHA collect. This one ended up having like 74 points per square foot, so it got quite a bit better. But here you can see the feature extraction again and how much more we actually had to extract on this one.
Yep. And on the bottom and the top, you can see the void areas where.
Yeah, I don't know if you can see my mouse, but the pink or purplish circles there are void areas that we ended up having to void out because it was really densely vegetated with either cattails or trees. I think in this instance, some of those were trees.
And we're the first ones that know the limitations of the sensor. I mean, we're like, nope, sensor's not meeting the accuracy requirements that we require. Get rid of it. I mean, we're not going to sit and force feed data that just doesn't meet our methodology that we want. So go out there, survey it by hand, get what we need.
Yep. And all of these are checked via cross section by traditional survey. We'll do a cross section, basically the full width of the right of way, and everything's checked within the TopoDOT software.
Ground truthing. You'll hear that a lot.
Ground truthing, absolutely. The next one is Highway 73. So this was our second project with the North Dakota DOT. This one was a little bit of an upgrade. We changed the sensors. We used a Ranger, mini Ranger from Phoenix on this one. So this one went from the first one, AL32S.
Yeah, AL32, yeah.
And then they switched to the mini Ranger, which is a slightly different type of sensor. It doesn't rotate. It's a fixed mirror. And it only has a fixed width. So this one wasn't the full 3D like some of the newer ones.
It's a really popular sensor right now.
Yeah. Yeah, it's actually gotten a lot cheaper, and it's able to be purchased by a lot more people now.
This project really did showcase, though, that density is the key.
Yeah, absolutely. So with this one, we did get a little bit more density. This one ended up being 92 points per foot. And we kind of changed some of our feature extraction methods on this one. Unfortunately, we changed it for the wrong, is what we found out. You can see here how this is really, really dense. This was I think this was like a 1 to 3 feature extraction. So for every few points, we extracted 1, and that's not the way you want to do feature.
Yeah, more data is not always better. I mean, this was a sheer thing of, okay, well, let's add more. You know,
just to see what happens.
More is not better. More makes MicroStation. It brings it to its knees. I mean, it makes design software, not work. I mean, so this was I was thinking we were doing something right, working with the DOT, and it just didn't work. So we learned a lot from it.
And this is a really good one too, because it shows every single brake line we pull. So we pulled the edge of pavement, the mid brake and the ditch bottom, and then the brake on the other side. Yep. There's a lot involved in feature extraction, even on a linear project.
It really is the changing part of it. We're able to pull full brake lines. Like, the hardest thing in the world to survey is a slide. If you know that, like, we're sloughing, where soil is falling away. It's super irregular. You have to go out there and shoot like every single brake. When you shoot LiDAR and lasers, it just paints it, and it's probably it doesn't matter. It just paints it, and we can feature extract exactly what's going on there. And it gives you really, really accurate quantities. I mean, that's what we're looking for, is to have really accurate quantities, plans that are really, really accurate, so we don't have to have overruns and change orders. I mean, it really is changing the way that digital design is working. So
the next project we ended up doing for the DOT was Highway 50. Yet again, another new sensor. This was the first introduction of the Ranger series for us. I believe this was the Ranger UAV.
Yep. And yes, it's North Dakota. I mean, all of these are kind of showing like nothingness with a road going through it. There is some things out there, I promise. We're probably showing it without the trees and bare earth. So.
These are all bare earth point clouds. So this one kind of went a little bit backwards on the point density, but that was just because of the new sensor. This one actually turned out probably as one of our most accurate ones to date. The non-vegetated surface was, I believe, at a 0.06 foot accuracy over the entire project. So that one we were really happy with this.
And this one was how long?
About
I think it's 15.
I think this one's 15. A lot of the early ones were 15 to 20 miles, and they continue to be that. As you can see here, we did a little bit different feature extraction method again. The white points in the background there are a gridded point. And then what you see in the red is what you call a feature, or a model key point.
Yeah, model key point.
So what a model key point is looking for is a break in the surface. Again, we were a little bit.
And this didn't happen very much after the last one. So I mean, again, we know we did too much, but this one was backed off.
Yeah, and we backed off a little, but we went a little heavier on the key points. But I believe this was the first one we actually tried to use key points on as well. So this is an OTTERTAIL bike path. This one's kind of a different feature extraction or a different collect. They're building a bike path through a very rural area of Minnesota. You can see the trees are dense. There's no way you're getting a traditional survey in there. It was even hard to get our surveyed cross sections.
Ground truthing was difficult. Yep. A lot of multi-pathing off the trees. Those trees are fairly big. Left view is top down. Upper right view is kind of skewed at an angle, like looking at a plane. And then the bottom right is a true cross section. So.
And this is the software we live in when we're doing this. This is MicroStation with a TopoDot toolbar.
So yeah, when Erik clicks the next button now, that is showing all the trees going away. So this is actually all the penetration down to the ground. And then this is what we actually do all of our feature extraction from. So you can actually see those. It's really hard to see on your guys' end, but there is some houses that are buried in those trees in blue. And you see them no problem. We can actually extract where they're at and everything. So this is a pretty amazing project showing the power of a really accurate, fast, dense laser flying over treed areas.
So WHETSTONE County, this is another area in Minnesota. I think this one's right on the border.
I don't know if it's a county. I don't know what it is. Maybe it is.
I don't remember if it's a county or city, but it's hard to keep track once you've done it.
WHETSTONE Project, I think.
This is what it's the WHETSTONE Project. Yep. It's right on the border of Minnesota and South Dakota, I believe.
Yeah, right in that bump in Minnesota on the west side. Yeah.
So this is the raw point cloud. This one was absolutely perfect as far as collection goes. It's a very irregular shape. I believe it was done for a transportation project and a hydro project. So they were concerned with the flow of the river coming through here. And then I believe they were going to do a road realignment in here as well. This was really one of our first multi-use flights. So not only were we going to provide data for the CAD system, we were going to export stuff for the GIS guys as well for the hydrology. This is a DEM created directly from that LiDAR point cloud. We process this on a different software that we use here. Basically, we can take and set the parameters for the DEM that we want. We can enforce break lines. We can do whatever we need. And then we can get them the hydro enforced DEM so they can do their hydrology designs inside of GIS and HEC-RAS.
It's amazing. I mean, it's kind of, I mean, we can do this with any project. I mean, we can make a DEM useful in Esri's ArcGIS software for any project. It just really did showcase that this one worked well.
Absolutely. And then this one is where we really started thinking and digging in on how to correctly feature extract. As you can see along the river there, we did a completely different method than in the open fields next to the river. What we did here is, oh man, that's not what I wanted. There we go. What we ended up doing is we ended up using those model key points a little bit more, but we toned them back a little bit so they're only pulling where the elevation is actually breaking towards the river. So you're going to get a super, super detailed feature extraction on the river, where in that field where you don't really need a super detailed extraction, you'll just get a gridded pattern. And then outside of that, that really white strip through the middle there was, I believe, a strip mine or a gravel pit or something.
Yep, with a lot of relief. The upper left corner had a lot of relief as well, and that's what you can kind of see is bluff edges. They're kind of like bluff edges, and it's kind of weird. They use those kind of tier things for farming and stuff, and it shows some of that too. So this is a really good project. I mean, all the roads were super accurate to be able to do the realign. Essentially, they're realigning that weird kind of angle road coming through there. So
yeah, on this one, we actually ended up on the raw LiDAR itself. This one, I believe this one was 644 points per foot. So this one was super dense, and we were able to pull everything we needed to pull out of this.
Yeah, so if you're listening, we went from, 60 points per foot to 600 points per foot. So pretty amazing.
Now we'll kind of move into the South Dakota DOT. This is I-90 through Piedmont. Here's a bridge section that we did, just kind of showing that you can pull the clearances from that. This was a mobile and I think this was actually our first mobile and aerial hybrid, if I remember correctly.
Correct.
This was a full topo survey. So from this LiDAR, we pulled everything that we could see. Roads, edges of pavement, parking lots, buildings, curbs, gutter, we had that.
Power poles, fences.
Yep, fences, buildings, you name it, it came out. Yeah. Again, this was kind of its first of its kind, and it was a different one, I'll have to say.
Yeah, I mean, it was kind of, not that we knew the concept was going to work. We didn't need a proof of concept. This one just was a full project that it showcased exactly that everything kind of worked out the way we figured it would. I mean, it was, one of our first LiDARs for the South Dakota DOT, and, we hope to do a lot more. We've done a few since then, and it's really worked out great. This one here I talk about a lot. It's a big area. It's a lot of LiDAR, but it's such a usable thing, and I hope the South Dakota DOT guys are happy with what they've been able to use from this for design purposes.
And going back to how we keep talking about the surveying from our desk chair, this was actually our first survey from a desk chair. And on top of that, this one has one of the craziest densities I think I've ever seen on a project. When they drove over those bridges, they were getting over 1,000 points per foot on the bridges themselves. So it was very, very impressive.
And the nice thing too, which I touched, is that we have all this data. So like, say the South Dakota DOT comes down the road and wants to do some work on the bridge that we're showing in the bottom left. We have that bridge completely painted top and bottom. We can pull all kinds of information from that. We can pull, clearances from any part of the pavement. We can pull all of that. And that's kind of an added benefit down the road that we give to our clients, that we have this ability to go down years later even and pull this information. And of course, it's your data. We give it all to them too. So, if they want to become, feature extraction specialists, they can as well.
Absolutely. Another one that we did for the South Dakota DOT was Highway 14A. You've already kind of seen some of the images of that. Very steep, very treacherous terrain that you're not going to be able to walk up and down to get a traditional survey. And again, very dense data. The image on the left there looks like a picture that somebody took. And here we've kind of carried through some of our other feature extraction methods that we've learned in the past, 3-4 years.
Yep. And there you can see the density changing outside of the design roadway extent. Yeah, we have points in that vertical rock face, but do you need a point every foot on a vertical rock face, or even like up every 10th? No, you don't. It doesn't make, but we have it. We have points. Frankly, every 0.05 feet, probably even more than that on the point cloud side, but you don't need that in a CAD world. You don't need that on the design part. It just slows your CAD down, slows your design down. So this one really worked out well we've got it dialed in essentially now. So all of our projects going forward are this way.
And as you can see here, each one of these pictures are taken from the pretty much exact same aspect. On the left there, you see there's tons of trees on the right side of that image. And then on the bottom right corner there, you see the trees basically stripped away, and you can see the river flowing
Yep.
below the road there.
And that cyan line in the bottom right there, that's, you know, kind of the edge of a creek going down there, that rip-wrapped kind of thing you can see there. So it's pretty neat to be able to have that kind of, you know, design edge, if you will, of that ditch.
On to the next one here. This is another different project that we did. This was a 100 square mile collect in South Dakota for US 212 bridge. This was the first one that we did from a helicopter. So this one was a very different feeling again. What we ended up creating for this was a 5-foot DEM and 1-foot DEM and 5-foot contours for the entire 100 square mile area. So what we had to do is we had to take it, we had to clean up the points, and then make sure everything was brake line enforced to create the DEM. And then we created the DEM in a different software so they could use that in a multitude of different softwares. So not only did we feature extract this one, we did the ability to bring this into GIS as well instead of just the CAD system. And then that is actually what we flew it with. And this is how the Ranger LR is mounted on the helicopter itself.
Yep, that sensor's very powerful. It's long range LR, so it really, really allows you to get up a little bit higher. But again, we're not flying this helicopter thousands of feet in the air. Yep. The way we get accurate information is flying slow and flying low. So we really do kind of, it's a big decision of how high, how fast, how, you know, where we fly and how much overlap. Those are big decisions that we talk a lot about, frankly, to get the LiDAR to be the way that we want it to be. So.
Yep, and that whole 100 square miles is roughly 300 or 3 billion points. It just kind of puts that into perspective on how much data we can collect, even over a large area like that.
Yeah, we acquired it in 2 days. All of it was acquired in 2 days.
Very quick acquisition. Next up is Highway 11 for the DOT, which we just did this past year. This was that 20-mile stretch we've kind of talked about. This was 3.3 billion points over that 20-mile stretch. I believe our non-vegetated accuracy on this one was 0.05 feet. So the accuracies and the densities we're getting on these are just phenomenal. We, again, had a hard time keeping up on the survey side to ground truth our data. That's just how accurate this stuff is. And this is kind of showing it, again, a little bit different type or newer type of feature extraction process. You see the center line and the road surface there, and then the pavement and the shoulder brake, and the purple-pink lines on, or the purple-pink points on the outside edges of the road are a new tool that was developed in the last year or so that really pinpoints the low spots in a cross-section. So you give a line and it basically railroads through and gives you the lowest points possible. And that's where your accuracies are going to show. And then we add the overall ground point.
Like the total extent.
Like total extent, yeah.
So say we want to go a certain distance outside of the right-of-way. That's what adds it. So
the pink points are basically from right-of-way to right-of-way. And
if you can see, this is a good example. Like all of those points are in a CSV and can be brought in and made, you know, in any civil program, you know, from that CSV to make a surface, and then you're off and running. So yeah, if you see through the road, we've got the center line in white, and then we have all those orange brake lines. So we actually do brake line enforced pavement surveys, which is kind of weird, but it makes it really accurate when we're bringing them in to, you know, to do design from. We're able to actually do what are they called? Sliver grading. Yeah, so we're able to actually maintain the accuracies to where we can give them quantities of what they're grinding out and how much they're taking out, and then redesigning it. So that's what I'm saying. I mean, the accuracy of this LiDAR vertically is at or even sometimes above GPS accuracies, especially when we're putting it on a stable platform like mobile and flying it from a helicopter, even a drone. The drones are so big that they're not whipping around and bouncing around up there. So,
yep.
All right.
That's kind of it for the projects. This is kind of a roundup of where we've been in the tri-state area of North Dakota, Minnesota, and South Dakota. We've actually worked on a few projects in Montana as well. Those were some longer power line projects, but 32 in total as of, I believe that was August of this year. And since then, we've actually added a few more in the Red River Valley here.
Yeah, I mean, this is great way to show kind of the diversity of terrain that we've been in. I mean, LiDAR really works in all terrains. It really flourishes, in some really hilly terrains. That's why we'll probably, hopefully, be getting some more, western-based South Dakota and western North Dakota down in the hills down there. But it's amazing, the LiDAR and how it does fill a niche, to make topographic surveys really usable. Other than that, yeah, I mean, we made it almost 45 minutes, which is about what we planned for. Any questions from anybody? We can unmute everybody if we want to let people talk. Yeah, so unmute yourself if you'd like to ask a direct question. I mean, otherwise, if you don't feel comfortable, looks like Heidi raised her hand.
Yeah, it's because we were paused before.
Oh. So yeah, if you don't want to ask in front of everybody, you could definitely give myself a call here at Houston. We'll talk all things LiDAR. I love talking about it. So it was all sent out in the information sent out with this presentation. Otherwise, yeah, I mean, oh, there we got some questions.
What, if any, ground truthing control targets are you doing? So for the ground truthing and control targets, typically we're doing a target every, mile or two, depending on the size of the project.
Yep, so minimum for our linear road projects, we're doing a visual target every mile, sometimes every half mile, depending on the terrain. And what that allows is it to be used in the initial processing. So, when you're doing the processing of the, trajectories and all of that, we can kind of have an increased influence from those targets to make it more accurate.
And as far as ground truthing, I think we still do a cross section every 1,000 feet.
It's about, every half a mile.
Oh, half a mile.
Yeah. But it depends on the client. North Dakota has a specification that they want for us to do. For ourselves, we maintain that, doing a cross section or ground truthing every mile for linear road projects. It's a little more difficult for the huge area type surveys. There we can just go out and kind of do more of a random spot check type thing. Do you have rough costs per mile for the scan and data extraction? Boy, if I had $1 for every time that was asked. It's really tough. I mean, location, mobilization are such a huge influence on, the project, and it can really change that cost per mile. It's not that expensive. I mean, I can talk with you, Kyle, at any time about, what it does cost. And again, if you do like 2-3 miles, it gets to be a little bit more expensive. But if you get up over that, 6, 10, 20 miles, because once you get a bird in the air, or a sensor in the air, I should say, it can go for a long time, and that's when you really start to get the huge, savings. But we've done many projects. I mean, we've done 5-mile projects. We just did a half-mile project up in Grand Forks. I mean, actually quarter-mile was pretty small, but we've done all kinds of different size projects, and we really do kind of try to make it a value for the client. So yeah, I apologize for not being able to say an exact cost per mile, because one, it changes all the time, because we're getting more efficient. Skyscopes is getting way better at what they do. They're moving around where they're mobilizing from, and things just change. Any other questions or information that you found, Erik, in the chat or anything?
Nope.
Nothing?
Nothing in the chat.
Well, I won't take up anybody else's time. I do really appreciate, though, everybody that showed up. I recognize a few of the names in there, so it's good to not talk to you, but hey, hopefully we talk soon. And hey, I'd love for any of you guys to call up on, especially the counties that were here, counties or states. Give me a call. It doesn't have to be even a specific project. Just say, hey, we're looking at this kind of a terrain. What could you do for me, or what kind of sensor would you think, or that kind of stuff. I mean, I'll talk to you guys about any of it. And on the county surveying side for linear road projects, don't be scared to say, hey, I've got 10 miles coming up. You'd be surprised at how inexpensive it can be. And for what you're getting, there's no comparison in what you're getting. You're getting so much more usable data than you are from a traditional survey that it really is kind of hard to compare. I mean, you're getting imagery top down of the day that we fly. You're getting all the feature extraction continuous. You don't have to have cross sections that you're kind of spanning between. You're getting a continuous survey. So if they're a digital designer in Civil 3D or MicroStation, they're going to love it. They're going to be so much happier doing a design from that. All your daylights become perfect, giving you super accurate quantities. And I mean, it is really a change. I've done a bunch of designs now this way, and I can't go back. Cross sections are pretty painful now. So yeah, again, thanks to everybody for showing up. Look forward to talking to everybody, and we'll probably do another one of these, I would assume, in probably anywhere from 3 to 6 months. Thanks, guys.